Okay, now let's learn the Hund's rule of maximum multiplicity. This we are learning. So we have come to the section, to subsection of the quantum model, quantum mechanics model of an atom, which describes the structure of atom. Um, Quantum mechanics which describe the structure of an atom. So now, after learning the quantum numbers and uh, after learning the Aubert principle, which says the electrons are filled up according to the increasing energy of their orbitals. Then comes the uh, Pauli's exclusion principle, which says that no two electrons can have the same set of four quantum numbers. That means in an orbital, only two electrons are possible, which will have three quantum numbers n, l, and m same, but it will differ in the first. In the last quantum number, the screen quantum number having opposite values, plus half and minus half. That means an orbital can accommodate on at a maximum two electrons, which will have different spin quantum numbers. Now the third comes the Hertz rule, like Aufbau principle, the Pauli's principle, and the Hertz rule. They are all uh, meant to the way the electrons are distributed in the orbitals, or electrons are filled up in the orbitals. Hertz rule of maximum multiplicity states that pairing of electrons in the orbitals belonging to the same subshell in a shell there will be subshells, right? In first shell, but in the first shell there's only one subshell. In second shell there are two. In the third shell there will be three subshells: 3p, 3s, 3p, and 3d, right? So in the same subshell, that means sp, not s is not required. P, d, and f subshell, which have the same energy, they are called degenerate orbitals. And orbitals having the same energy, or orbitals which are in the same subshell, they have same energy depending on the number. And having same orbitals means the value of L is same. That means they have n plus L value is same. That means they have the same energy. So orbitals having same energy are called, or orbitals of a subshell are called degenerate orbitals. So I want you to understand what's the meaning of degenerate in terms of orbitals. Degenerate orbitals having same energy level, same amount of energy, does not take place until each orbital belonging to that subshell, this is S, P, and D, P, D, and F subshell, has got one electron each. One electron should be filled up first. That means it is singly occupied. All the orbitals, all the degenerate orbitals should be first singly occupied. Means first there will be one electron should fill up first. Maximum two electrons. There can be an orbital that can be maximum two electrons, which is as per the Pauli's exclusion principle. But before having two electrons, it should first be singly filled. Which orbitals? Which are having the same energy, or the degenerate orbitals, or orbitals of the same subshell. So let's try to understand two diagrams. Say, suppose in the fourth shell, n equal to 4, there will be four subshells: 4s, 4p, 4d, and 4f, right? That means there are four values of L. L may be 0, 1, 2, and 3. When L is 0, it is S subshell. When L equal to 1 means P, L equal to 2 means D, L equal to 3 means F, right? When L equal to 1, that means there are three possible values of M, minus 1, 0, and L. When L equal to 2, there are five possible values of M. It will be minus 1, minus 2, minus 1, 0, plus 1, and plus 2. When L equal to 3, there will be 7 possible values of M, twice L plus 1, minus 3, minus 2, minus 1, 0, 1, 2, and 3. So 7 values are there. What does this 7 values mean? It means different orientation. And what does the value of L means? It means the shape of the orbital. L equal to 1, P equal to P, which is dumbbell shape. L equal to 2 is D, this is double dumbbell, and so on. But what does the rule say? Rule says that suppose this is P orbital, right? Or this is 4p subshell, right? These are three orbitals, 4px, 4py, and 4pz. Three orbitals or 4p subshell. In the 4p subshell, there are three orbitals because there are three possible values of m. So when you fill up with electrons, right? What you have, suppose there are three electrons. If there are two electrons, you should not fill the first orbital completely, like two like this. First, you have to distribute it in all the three orbitals because these orbitals, they have the same energy. So first fill up them singly, then pairing will come up. So if there are four electrons, first electron will go to this, then second to this, and third to this. Fourth electron should be paired. So this is the right way. So what about here? Suppose there are four electrons, which is going to fill up in the 4d orbital. How will it do? Can you fill up like this? You fill up for the first orbital, you pair it up, then second orbital you pair it up. So this is a wrong way. How will the four fill up? You fill up first 1, 2, 3, 4. It should go first. There should be first the orbitals of sameness should be singly filled. You should not go with doubling. First you fill them singly. So if there are four electrons, you fill up next 1, 2, 3, 4. If there are five electrons, you should not come over here. This is wrong. If there are five electrons, first this should be filled because they are all of same energy. So the orbitals of same energy or degenerate orbitals should be filled up singly first. It should be singly occupied. First you should make sure that one electron is occupied in all the orbitals or all the subshells, all the orbitals or subshells. Then after this only, when the 6, 1, 2, 3, 4, 5 and 6 electrons come, then you can start pairing. If there are 7 electrons, then this will fill. If there are 8 electrons, then this will fill, like this. So make sure that when electrons are filled up, the orbitals, the degenerate orbitals or the orbitals of the same subshell, each of them are filled up singly. Fill up with one electron first, then you should start pairing. For example, this is 4f. So in 4f there are 7 possible values of m. That means there are 7 orientation possibles, right? So there are 7 orbitals which are having same energy. These are all 4f, 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 4f. 4 is subshell and 7 orbitals having same energy. How will you fill up? Suppose there are 1, 2, 3, 4, 5, 7 electrons. You should not be pairing up like, if there are 7 electrons, if you start like this, so this is the wrong way of starting. First the same orbital should be singly filled. Yes. Then you start pairing. So after first, second, third, fourth, fifth, sixth, 1, 2, 3, 4, 5, 6. There should be 7. Strong. There's 7. 1, 2, 3, 4, 5, 6, 7. Then you start pairing 8. So 8 electron, you start pairing, not before that. When there is 8 electron to fill, then you start pairing 9, 10, 11, 12, 13, 14, like this. Fine? I hope you have understood.